AP Calculus free response preparation. You can pause this video at any time. We will go through parts A, B, C, and D. All right, so for short, part A really wants us to just use the table to estimate the derivative of W at 12. So I went ahead and wrote down the table values so that you wouldn't have to go back. So let's take a look at these table values, and remember, we're looking for the derivative at 12. Remember, 12 isn't on this table, but we know that 12 is going to be in between these two values. So literally, all we're doing is setting up a slope formula using these values. Remember, the y values on top, x values on the bottom. All right, so I set up my y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If we were to just look at it just from a straight up basic level, that's all we just did. A regular slope formula. Now remember, these numbers are measured in Fahrenheit. These numbers are measured in minutes, and that is literally your answer. Now, it's up to you if you calculate that and turn it into a decimal, but just to be on the safe side, just know once you do this, you are done with that question and you will get all of your points. So at t is equal to 12 minutes, the temperature is rising at a rate of 1.0166 degrees Fahrenheit per minute. That's your interpretation. Now for part B, we are going to use the table to evaluate the integral from 0 to 20 of w prime of t dt. Now remember, that's asking for a w prime of t, but over here is not a w prime. So this right here, believe it or not, is a fundamental theorem of calculus question. So the fundamental theorem of calculus states that if you take an antiderivative of a definite integral, it's going to give you the antiderivative at the upper limit minus the antiderivative at the lower limit. All right. So remember, if this is a w prime, the antiderivative is just w. So what we have to do is a w at 20 minus a w at 0. That's how we complete a fundamental theorem calculus question. That's how we complete the setup. So using the table, there are my values right there. I see where 0 minutes is, and I also see the value at 20 minutes. So those are the two that I focus on. So at this point, all you're doing is taking those same values from the table and subtracting them. And that gives us 16 degrees Fahrenheit. So to interpret what we just did, all we found was the displacement between 0 and 20 minutes. So there's a 16-degree difference between where we started and where we ended. All right, so now we're given the expression to calculate the average temperature. We're going to use a left Riemann sum to evaluate it using the table. So remember, using a Riemann sum is basically just finding areas of rectangles. That's pretty much all we're doing. We're finding areas of rectangles. All right, so here's my table, and I'm broken it into 1, 2, 3, 4 subintervals. And from here to here, that's a 4-minute interval. From here to here is a 5-minute interval. From here to here is a 6-minute interval. And from here to here is a 5-minute interval. So that's going to be the first thing that we find first. We're going to get those numbers there. Now, the next thing is we're doing a left Riemann sum, which means I start on the left and I do this number, this number, this number, and that number. So I start on the left, and those are my 4. 1, 2, 3, 4. Now, what that means is all we're going to do is multiply everything out from here. So I'm multiplying 4 times this number, 5 times that number, 6 times this number, and 5 times that number. And I'm adding them all up. So basically that's my area of a rectangle plus another area of a rectangle plus another area of a rectangle plus another area of a rectangle. I have the area of 1, 2, 3, 4 rectangles, and I'm dividing by 20. And so whatever my answer is going to be an average temperature. You can simplify it further, but I will leave it right here to ensure that I don't make any more errors in my calculations. Now the next thing we have to do is determine if this number that we got is an over approximation or an under approximation. So our evaluation is an under approximation, and I will give you the explanation in 1 second. Since the function w is increasing over the whole interval from 0 to 20 minutes, a left Riemann sum is an under approximation. I'm about to go into a visual explanation for those that need to see that. So in general, if we were to look at where we started, which was 55 degrees Fahrenheit, to where we ended at 71 degrees Fahrenheit, and I broke it along those numbers directly from the table, which is 0, 4, 9, 15, and 20. If I were doing a left Riemann sum, that means I'm starting at this 0 and I'm creating a rectangle that goes there. See? And here's my rectangle right there. Remember, I'm coming from the left, so I'm coming this way, and there's my other rectangle. I'm coming from the left, and I'm going this way. There's my other rectangle. I'm coming from the left, I'm going this way. There's my other rectangle. So if you pay attention to what I just colored in, there's gaps here. That means whatever I add up here is lower than the actual average if we were to take the full amount or color the whole thing in. This is an under approximation. So part D adds in something that's not on the table. Part D picks up with giving us a rate of the temperature at 20 to 25 minutes. So now we're going further than where the table took us now. Now what this wants to know is, based on the rate, what is the temperature at the water at 25 minutes? All right, so now I think this is a good time to mention this. The question that I'm looking at today is a calculator question, right? Notice, this is the only part of the question that actually requires the calculator. We were able to do part A, B, C without a calculator. But now that we're on part D, I think this is the time where we would actually really need to use that calculator. So before we get into the calculator part, I just need to go into the setup. Now, this right here, we're finding the antiderivative of this, because remember, it wanted to know the temperature, not the rate of the temperature. See, W prime of T is the rate of the temperature, but W at T is the temperature itself. So this is a fundamental theorem of calculus question, because once again, the antiderivative of a W prime is just a W. Now we got to do W at 25 minus W at 20, but that is our fundamental theorem of calculus question. And just like any other time, that can be shifted over to here. So now I have a W at 20 plus the integral is equal to my W at 25. Now, W at 20 is a number that we actually know from the table. So the next slide, I'm just going to punch everything into a calculator, and then that's going to give us our temperature at 25 minutes.